Hi, it's week 5 of Florida Virtual 6.08a Pythagorean Theorem on the coordinate plane. We're looking at how can you use the Pythagorean Theorem to find the distance between 2 points on the coordinate plane. So the first example here is a mountain bike problem. Evan was biking on a trail. A map of the trail is shown. His brother timed his ride from point A to point B. What do the blue and red lines on the graph represent? So we can see here on our grid that these are our legs. Remember, this is our rise and our run, like a slope triangle. So these are the legs of our triangle. And this red line is the hypotenuse. Next, what type of triangle is formed by the lines? Well, we can see here that we're going to get a right triangle. And then how can you find the length of AC and BC without counting the number of units? So we could count up, but as you notice here, we get a 9.5. So it's not full units. So what can we do to find segment AC? Well, we can take those points and we can, just like when we're using the slope formula, take the difference between the x's. So that's equal to the second x minus the first x on that line segment. And then for segment BC, that's on our y-axis. So we want to take that second y minus the first y. So let's do this algebraically. So x2 and x1. So we have 7 minus 3. And then our y2 minus y1, 9.5 minus 4. So our lengths for AC and BC are 4 and 5.5. From here, we're going to look at writing an equation using the Pythagorean theorem to find the length of AB, because AB is just simply the hypotenuse of a right triangle. So we know the two legs are 4 squared, and then we're going to have 5.5 squared. And we're looking for C. So this is A squared plus B squared equals C squared. So let's square the 4, square the 5, and then continue to simplify. So when we add these together, we get 46 and a quarter. And we want to get the C by itself, so remember we're going to use the inverse operation. So the opposite of squaring a number is the square root of that number. So C is equal to, or really approximately, it rounds off to 6.8. And remember, that could be a positive or a negative, because regardless of it squaring a positive or squaring the negative of the 6.8, you're going to get a positive answer. But the length of this ride up here would be approximately 6.8, and I'm going to guess miles, but it doesn't say specifically what measurement we're using. This was 4, this one's 5.5, whatever units they were using to measure the ride. All right, and remember, if you need to, you can always pause the video and copy this down. All right, on the next page, and if you did like I did, I folded it together. We're looking at finding the distance on the coordinate plane on this left side. And the first thing it asks you to do is, let's find the distance by graphing. So we're going to start by plotting 1, 3. So we can go right 1, up 3. And then we're going to go -2, so that's left 2, and then up 4. And you can take an index card and draw a straight line, or you can use a ruler, or you can use a protractor if you have one. Anything with a straight edge. And then from there, we're just looking at creating that right triangle. And then what is our rise over run? So for this problem, we can see our rise is 1, our run is 1, 2, 3. And then you're just going to set up your problem knowing that this is a right triangle. A squared plus b squared equals c squared. So let's go ahead and so you can pick either number as a. I'm just going to use 1. So 1 squared plus 3 squared equals the c squared. So what is this distance? 1 squared, 3 squared is 9, c squared. 1 plus 9. And then last step, remember, inverse of squaring a number is its square root. And when we square a number, positive or negative, it's still positive. So the square root of 10 is 3.2, approximately. And this is a positive or a negative. Now, because it's on our coordinate plane and we're measuring that distance, it is a positive 3.2 equals C. One more thing before I move on to the next problem that is only using the 2 points that join the hypotenuse endpoints is I want you to notice how these 2 points on the hypotenuse, the x's they have in common here on the rise and the run, they have the y in common. So when we're looking at the distance formula, just because we're not using these points with the rise and the run, we really are, but we're having to include that distance, that 4 that we're missing, and then also the distance here with that 1. So using the distance formula, we can find the distance between the 2 points by using this formula where d is equal to the square root of second x minus the first x squared, just like you did on the other page, plus that second y minus the first y squared. We're given the points 3.5, 1, and -4, 2.5. So just like we did with slope, we're going to kind of use that same concept here because we are finding the slope, but now we're finding not just the slope, which we know is our rise over run, but what's the distance between those 2 points on that slope? So let's set this up. D is equal to, we have this long square root sign. So -4, this is x2 minus x1. -4 minus 3.5. And square that. And then we also have our x's, our y's. So we're going to take 2.5 minus that 1. And square it. So from here, let's start simplifying. D is equal to, it's going to get a little bit shorter. -4 minus 3.5 is -7.5, and we're going to square that. And then we have 2.5 minus 1, which is 1.5 squared. And we have to simplify before we start squaring all of this, finding the square root. So -7.5 squared gives us a positive 56.25. 1.5 squared is 2.25. Add those together. You get 58.5. And again, the last step here, now this is our hypotenuse. We're not using the c squared here because we're using this distance formula, and that square root is already built into this distance formula. So D is equal to 7.6. And again, this could be a positive or negative, but because we're looking at the side of a triangle, then our answer is going to be a positive 7.6. So going back to our EQ, we're looking at what do we do when we are using the Pythagorean theorem to find the distance between 2 points. So as we did in the problem over here, we know that you're going to plot the coordinates.
I think it came out.
You want to draw a right triangle. And then use the Pythagorean theorem to find the length of the, well, that slope is our hypotenuse. And then at the bottom, so it says on the map, each unit represents 45 miles. West Point, New York is located at 1.5, 2, and Annapolis, Maryland is located at -1.5, -1.5. What is the approximate distance between West Point and Annapolis? So this one is done for you, but if you have to apply the distance with, let's say, on a map, you know, with that extra step, and we're looking for Annapolis to West Point. Here's Annapolis, I think. Here, right here. And then here's the rest of our triangle. So we're looking at using the distance formula or using the Pythagorean theorem by finding what is our run and our rise on this right triangle. So there's the two methods they use here. Method 1, finding the distance between Annapolis and then this point on the graph, and then likewise the rise. You're going to come out to 4.6, positive or negative, and then here using the distance formula, plugging in your points for x and y, finding the difference, adding them, squaring them, adding them square root, and then approximating it again, you get the same answer. From there, you have to take that distance because it's saying that those are just 4.6 units on the map, and each of those units is equal to 45 miles. So you're going to take that 45 miles times the units on the map, and we would get about 207 miles difference or distance between those 2 points. So just for reference, on the back, you have a couple problems on the grid, and no lines here, but we do have the points that are marked. Notice when we're looking for the distance on the x, we're going to subtract these -10 minus a -3. Remember, plus a negative is, positive. Likewise here, -1 minus a -6. So that's -1 plus 6. And then you can either set it up using the distance formula, or you may just want to write your rise over your run and use the Pythagorean theorem. Likewise here, if you're given just 2 points, you're going to find the difference between the x's, the difference between the y's, square them, add them, find the square root of that, and you have the length of your hypotenuse. So if you're having any trouble, please make sure you join the Zoom on Thursday. I may put one in for Wednesday, or just go back, take a look at the notes, walk through it again a couple times if you need to, or you can email me with any specific questions that you have. You should do really well. Most of y'all did great with slope, and it's just kind of a rehash of slope and using it in a new way with the Pythagorean theorem. Look out for my next video on volume.